Hey guys, it's Vince. Today in this video I'm going to discuss a redundant topic I've spoken about quite some time, but for some reason the point just seems to keep getting missed. So what I really want to do is a detailed video, and hopefully with this kind of detail that I'm putting into this video, it will really help those who have any question about the topic of heat regulation on their CNC controller. Okay, I don't care if you're using a Chinese-based driver system or a Gecko-based driver system. If you are using any type of internal power supply, especially in an enclosure foundation, you definitely need to concentrate on both a heatsink and a fan combination. Okay, heatsinks simply mount on the back of your driver system. This is the trusty G540 right here. These heatsinks mount utilizing thermal epoxy. Okay, we're going to mount them right here. We'll line up all three using thermal epoxy. Once again, after scratching the back of this, you want to definitely create a mechanical adhesion principle. You can see some oil there where they actually put in the mounting of the aluminum case. So I would definitely go in there. That's where all the drives are mounted. I would go in there, and you want to wipe the back of this with some acetone. Make sure it's nice and oil free. Scratch up the back, clean it again with acetone. Do the same thing on the back of the heat sinks to make them nice and rough so they adhere well with the thermal epoxy. The thermal epoxy to use is Arctic silver. It actually has micronized silver in it, which helps to actually formulate the heat to pass through very easily into the heatsink material. That's what we're looking to do, guys. Okay, once that's been done, you're definitely going to want to look into an industrial rated cooling fan. Okay, this is a Sanyo Denki cooling fan. This is all I use in my systems. It's rated at 48 volts, pulls about 1 amp of power. This fan is no joke. It runs at 10,000 RPM. Okay, 10,000 RPM puts out 60 CFM of cooling volume. Okay, CFM stands for cubic feet a minute. That's a lot of air, guys. Okay, and I do that intentionally because these drives are no joke. Okay, when you're talking about getting over 200 degrees inside of an enclosure, you definitely require an optimal amount of cooling. Now that being said, remember, you're not just running the Gecko inside your unit. Okay, we're also running a power supply. So when your power supply is inside that enclosure with the Gecko, you're also going to be generating even more heat. So take that into consideration. Ambient temperature is never ever calculated in. I hear guys tell me all the time, well, my shop is cool. What's cool? What's cool to you may not be cool to me. Cool to me is a shop that ranges probably in the mid 70s. Okay, somewhere 73, 74 room temperature. That's cool. If you keep it at 70, you're even better. Because I can tell you right now, by the time you turn on your equipment and start running for a couple hours, that temperature will go up. Okay, especially if it's early in the morning, right? Common sense, it's cooler in the morning. And then as you run your shop, it keeps going up higher and higher and higher until all of a sudden you notice your machine acts wonky and, you know, oh, I don't know what's going on. I can't figure this out. The machine is acting strange. You know, this, okay, but I've used the machine. It works great. I've used it now for 5, 6, 7 hours and I'm having problems. 9 out of 10 times, the first question out of my mouth is every cable shielded? Is the machine earth grounded as it should be, along with all the cabling? And I always get that same answer. Yes, it is. I've done everything you've talked about. I've done that. It's all earth grounded. Okay. Then the next thing to look at is heat. Why? Because heat, naturally, it grows hotter, the equipment, as the day goes on. If it's early in the morning, it's going to keep growing hotter. And then on top of that, with the equipment we're using, it gets very hot. Stepper motors that you're running at 48 volts that are typically meant to be rated at like 3.6 volts, you're running them 12, 13 times greater than what they're rated at. Okay, so the more we keep doing that and the larger the ratio of voltage we put into a stepper motor, naturally it generates more heat. Guys, there's videos on YouTube that you can actually see them cook eggs on a single stepper motor. Okay, if you're running 3 of those and they're each getting close to 200 degrees, then you're running a spindle that's pulling 8, 9 amps at 220 typically, 220 volts, you're generating mass amounts of heat. Okay, and that's before we even get to the controller and the power supply. So then your power supply and controller is generating another 200 degrees, plus you got an exhaust fan that's now blowing all that heat out into your shop. What do you think is happening? You know what's happening, so do I. You know, for those who don't believe what I'm saying, just I dare you to grab a Gecko after an hour of heating up, and you're going to find out real quick what I'm talking about. These units get hot. I've had people tell me that they don't feel that the Gecko is getting hot because their enclosure is not hot. Guys, this is not your enclosure. This unit is encapsulated and actually has the 4 drivers integrated into it. This is what you want to read the temperature on, not your enclosure. Okay, your enclosure is not going to act as a heat sink. Okay, your mounting platform on this, I don't know if you can see this, you've got about a 2 mil thickness in aluminum here that actually mounts the front of the Gecko. You want to make sure that the back of the Gecko, if you're going to take an accurate temperature reading, you want to run this unit for about 3 or 4 hours, take an accurate temperature reading back here. But I'm going to do you one better than that, because this topic keeps coming up and I wanted to figure out a way to isolate really figuring out if your system is actually having fallacies from overheating. And I came up with a way that you can actually figure out and determine if it's overheating. Okay, first and foremost, any of my systems come stock with the cooling package you see before you. I install this on all of my systems that I build turnkey for that reason. And generally speaking, they work fine. Okay, typically though, I get guys that buy kits. They end up buying these components separately. They install them themselves. Still, no problem with that. The problem is we're not thinking about our environment. Okay? If you're going to put your machine in your basement or in your garage, because I live in Florida, I can tell you right now, the heat in Florida is ridiculous because you're not just dealing with heat, you're dealing with humidity. Texas, you're dealing with a much drier heat. Nevada, so forth. Out west, you're dealing with much drier heat. Heat is heat, guys. When you mix heat with humidity, though, it's absolutely horrific because everything rusts. You're dealing with a lot higher water content in the air, and there's just more problems. Overall, though, I want you to think of your CNC robot as more of a computer than an actual piece of hardware. A lot of guys forget that. You know, just because your table may be made out of aluminum or steel, it does not mean that it's not susceptible to heat. Aluminum and steel will heat up greatly, especially if you've been doing milling for quite some time. Grab your spindles mount and you'll definitely feel heat if you've been actually milling for quite some time. If you're doing a couple hours, 3, 4, 8, 10 hours of machining, you've got to compensate for what you're actually doing. And if you're in a garage or a basement, and let's say it's 1,000 square feet, and the ambient temperature in that location may be 80 degrees, by the time you start running all your equipment for hours upon hours, that temperature is going up exponentially. So you need to really think about that as you go and build your system. You know, I've had past clients tell me they've encapsulated their machine because they were worried about dust and whatnot, and then they didn't actually install an exhaust fan with a filtration system. So basically what they did is create a convection oven. You know, we don't want to ever do that. We don't want to burn up our components, and that's exactly what you'll end up doing. I mean, stepper motors each get to about 200 degrees. You have 3 of them on a 3-axis system. Then you have your spindle that's running at about 8 to 9 amps at 220. That's generating heat. If you put a box around that to keep your shop clean, that's great. Make sure you're installing about a 200 to 300 CFM exhaust fan with a filtration system so we're not sucking in all the dust and debris that you're creating with the machine, and you have a way for that system to breathe. Otherwise, you might as well just throw a cake in that oven and bake it, because that's exactly what you're doing. So once again, I hope this is expressing to you the importance of what you're dealing with when you're dealing with CNC. We're merging computers with machining. And when we do that, we have to take into account the electronics that we're dealing with. This system is not designed to be installed outside. I have a couple people that have these outside, especially in Florida where I am. If you have these outside in Florida, you're dealing with mass amounts of humidity. So again, you're dealing with lots of water in the air. Think of water and electronics. I don't think I really have to cover much more in detail to really figure that out. You definitely don't want to deal with humidity and electronics. It's horrible. Okay, this equipment will not last. I don't care if it's this driver. I don't care if it's the Chinese drivers. We have to execute common sense at all time. Okay, like I explained to you earlier, I did figure out a way for you to determine if you're really thinking your system is suffering from overheating, or if you want to do a test. There's an item that you can purchase to do a test, and it'll work exceptionally well to not only protect your system, but to let you know that your system is actually suffering from overheating symptoms. Okay, the Gecko is rated to run safely at about up to 140 degrees. Okay, that's about the safest temperature to run her, and you're probably pretty much good. You probably could go a little higher than that. I wouldn't suggest it, because then you're risking damage. And really, the cooler the better. Okay, excess cooling you're never going to have problems with. Excess heat you're always going to have problems with. Logic speaks. So here is the device that I want to introduce you guys to. This right here is a thermal switch. Okay, I sell these in my cooling package in my store. Now I have an advanced cooling package which I've never done a video on. And what that comes with is everything you see before you. It's called the Vampire cooling system, and it also encompasses this thermal switch. This thermal switch is a really neat device. It's rated at 60 degrees Celsius, 250 volts, and 5 amps. So 48 volts is nothing to it. When you buy the Vampire cooling system, you get the switch, and you get everything you see before you here. And how this switch works is basically you're going to get the normal cooling system, and with this switch you want to wire this in, and I have a demo power supply here to show you how to wire this in and show you exactly how this works. This is your wall input. This is the typical IEC power input that you would use on a computer or a box build. Again, snap-in fit, nothing special, same old thing. You've got the L output, and let's see if I can actually see it, because this is a very tough line to actually see with the right light. You might be able to see it right there. Either way, the wire is actually hooked up to the L output on this port. When you run that L output, and you can see I use black to color code it, which typically in most circumstances for electrical with AC, that would symbolize hot. I ran it to a terminal block, okay? And the terminal block, the 2-point terminal block, splits off into this switch. One end goes into the switch, one end passes back out, and then brings that all the way over to the L input on your power supply. Okay? And what you would do with this switch is you want to mount it probably on the back side of your G540 or your heatsink package. You want to mount it as close as you can, probably either on the side of it, on wherever the heat sinks are. You're probably not going to have much room on the heat sinks, but on the side you'd be set to go. Again, utilizing thermal epoxy because we want to transfer as much heat as possible. Once you do that, okay, this switch becomes active. And what I mean by active is she's basically watching as a guard dog. If it gets past 140 degrees, it's going to trigger itself to cut out, and it cuts the power to the power supply, because if you look closely at what we did, we ran the AC coming into the box, and you can see here into the terminal block, goes through the switch, and then wires it right directly into your power supply under live. As soon as that switch gets too hot, it triggers the power supply to shut off, because it shuts itself off, and it protects your unit until it cools down and resets. That's why I call it the Vampire cooling system, guys, because you can't destroy your drive. Okay, that was why I came up with that. It's the only one on the market. Okay, and I will tell you it works exceptionally well. The thing to take into consideration is I'm using a 2-point terminal block, and I want to just discuss that a second. Why am I using a terminal block when I'm not using soldering? Because I created a subsystem. I speak of subsystems all the time. If you have to service your unit and remove your Gecko for some reason, the last thing you want to deal with is make a permanent connection like a solder point. But if you solder this to the Gecko, or excuse me, I'm sorry, not solder. If we use thermal epoxy and attach it to the Gecko, what we're going to do is essentially just unscrew the 2 points that attach the switch to the terminal block, and you can leave this inside your box and then remove your Gecko and you're set to go. It does not matter which correlation you hook these wires up in inside the terminal block, because it's just simply creating a circuit, just a single loop similar to a resistor. So that's essentially what we're doing with this. This switch can be used by itself as a tester to see how hot your system is getting. You don't need to buy this package, okay? If you don't want to buy this package as a Vampire cooling system, that's fine, okay? But if you want to test your system, you want to buy a thermal switch. If you contact me, I'll sell them to you. They're cheap as hell, and they're going to give you the best performance by doing just what I said. You can wire it in just like this without the cooling system, okay? You'd wire it in just like I've got here. L output on your input of your AC, wire it over to your terminal block, come in here again, One end of the switch actually hooks up to the terminal block. The other end of the switch hooks up to the terminal block and then goes over to your power supply. If your system shuts off within, let's say, 2-3 hours, you know you're cooking your system. You know that this just protected your butt right there. Because if it starts acting weird and you start getting weird controls and, you know, things start acting really strange, things lock up, seize, missteps, I'm telling you now, it's heat related. This will confirm it because it'll just shut your system off. And until it cools down, you will not have your system be able to be turned on. That's the brilliance of this switch. It self-resets itself. Once it drops below 140, it'll reset the system and you'll be able to turn it back on. These are the same devices used in most high-end electronics to protect them. I figured, why the hell can't we use them in our electronics? And that's when I designed it. I said, let's put it inside of a cooling package, and that's when I came up with the Vampire cooling system. But now it's come to a point where what we're doing, we essentially want to make sure we eliminate as many variables as possible. And I have a lot of guys that don't want to spend a lot of money but want to test their system and see if it's fabricated correctly. Look, I don't care if you guys use my components, okay? But one thing I do care about is being safe. Heat can cause a lot of problems, not just destroying high-end electronics, okay? It can cause fires. It can do a lot of nasty things. And realistically, you guys are trying to do it right. I'm speaking to the guys that want to do it right the first time. They want to understand exactly what they're getting involved with. And when you deal with robotics, that's something we have to take into consideration, is the fact that you're dealing with a lot of moving components. Moving components means more heat. The more heat we deal with, the more variables that can affect us. And in this situation, heat with your controller is detrimental. Okay, it'll lead to a lot of problems, especially, and I can't emphasize this enough, and this is some of the actual comments I've received from people, is that typically their machine will be running good for, you know, 4 to 8 hours or 4 to 6 hours. Everything will be good. Maybe that first minute after 6 hours, the temperature goes up. They end up making a blem on a part that they're machining. And why is that? That's because the temperature got to the point where the system no longer could withstand it, and it starts acting up. The next thing that happens is damage. Okay, if you continue to push it, you're going to damage it. It's no different than a human getting heat stroke. That's what's happening to the electronics. Okay, I've had people tell me they've put, you know, they've taken the enclosure apart, they've put fans over their enclosure. I mean, we need to think logically, guys. Climate control today, if you have this kind of shop equipment, to invest in a second-hand air conditioner is not hard to do, and it's not expensive. If you need it, do it. All of my area is air conditioned for that reason. I don't take any chances. I keep my equipment like new, and it treats me like new as well. So you have to think in them terms. Is it cheap? It's not always cheap. This is not a cheap endeavor. If you're looking for cheap, then I seriously suggest you buy the smallest mill you possibly can buy and then worry about running it where it suits you. But if you're buying a large mill, and I say that in terms of router or mill itself, full scale, knee mill, whatever it may be, you have to think in them terms, because the more we use our electronics, the hotter that condensed area becomes, because again, it's dissipating heat. So we need to keep that in consideration. Once again, if you guys are interested in getting one of these thermal switches to test your system and see just how hot it's running, this is awesome because it automatically kicks out. I've had guys install thermostats inside their equipment. You can do that as well. This is a no-brainer. Okay, you can put this in your system, forget about it. Don't even worry about a cooling system, because even if something happens, this will automatically just kick off your power. The way that I've got this wired in right here, once again, the brilliance of it is number one, it's removable because we use the terminal block. And again, you use thermal epoxy, you can always pull your drive out, you're good, and you rehook everything up and you're set. The next thing is great is that you're protecting your actual power supply, and you're protecting the Gecko itself from heat. So again, this little investment right here, it's amazing what it can do. $8 shipped on my store if you need it. I didn't do a listing yet for this because I've been selling it complete with the actual Vampire cooling system. But if you needed one, just message me. It's $8 shipped, and I'll get one out to you. And again, for $8, the investment, it tells you a lot, and it'll take away the guesswork of whether or not your equipment is really set in an environment that it's controlled. Okay, if your drivers are getting hot, if you have a Chinese driver system, you can hook these directly to your drivers as well. So again, it's really up to the end user on what they want to do. But overall, keep into consideration, first and foremost, you definitely want to go with the basics. Heatsink fan, definite. I don't care what system it is. I don't care who makes it. Go with the heatsink and fan and you'll be set. Once again, I hope this video has helped. I hope that me covering in detail about this drive, because again guys, this driver is amazing. If we take care of it, we treat it like the important piece of component that it is, you'll be fine. Okay, I can't emphasize that enough. Protect your investment. These are about $300 a piece. They are no joke. If they are taken care of, they work amazingly well. Just execute common sense. And again, if you have any questions, ask. Don't make the mistake of assuming, because assumption, we know what that is. It's the mother of all screw-ups, right? So let's just make sure that we're on the same page, and hopefully this video, once again, covering things in this kind of detail, has eliminated any second guessing. I hope this has helped. If you guys have any questions, once again, my name is Vince. Thank you for your time. Take care.